Next book is Lee Smooth Manifolds book, which is part 2 in this trilogy, which has now 4 books. So this is, I think, is a definite book on manifold theory. It's immensely well done. It does everything in differential geometry that you want: smooth manifolds, smooth map, tangent vectors, submanifolds. It has Lie groups, vector fields, integral graphs, vector bundles, differential forms, metrics, orientations, integration manifolds, de Rham theory, quotient manifolds, exponential map, symplectic manifolds. It's a book that does everything, I think, in differential geometry, or at least smooth differential geometry, the right way, and a way that I really like a lot. The theory is really well explained. It has problems throughout the book, throughout the text, but also problems in the back. This is really a book that I loved working through. A book on quantum mechanics I'm currently working towards is Hannah Buss, Introduction to Quantum Theory, which is a very mathematical view towards quantum theory, but not so mathematical as for mathematicians. So it does gloss over some stuff, but it's fairly nice still. So it starts with wave mechanics, a lot of wave mechanics, hydrogen atom scattering. Then it goes towards the mathematical structure, the commutation relations, angular momentum, symmetry, measurement and paradoxes, alternative formulations. Then it has stationary perturbation theory, variational methods, the semi-classical approach, several particles, relativistic wave equation, Dirac particles, elementary particles. Yeah, so this is a book that I love very much to work through. It's a book that I recommend to everybody who is a bit mathematically focused. The problem with this book is don't expect philosophy in this book. Don't expect much applications. This is really a book about the math of quantum mechanics, but still quantum mechanics, right? It's not that it's pure mathematical. It's all quantum mechanics. Then we have the book, The Terror of Nations. This book needs some introduction. Everybody knows this book on the server. It's the Ostermatt. It's first volume of this multidimensional real analysis. It's beautiful. It's just beautiful. It has continuity. It has differentiation. It has inverse function, Laplace function theorems, manifolds, tangent spaces, and then volume 2 has integration, submanifolds, and oriented integration. The thing with this book is that the theory is very dense. It's definitely not a good way to learn the theory, but the exercises are immensely nice. See, the exercises are all collected towards the end of the book, right? He's here, the exercises start. See how this is the theory at this point, and these are the left of the exercises. The exercises are brilliant. The exercises are so brilliant. Here you see Newton iteration, for example, exercise. You will see the smoothness of eigenvalues. Here we see how many degrees of freedom does a bicycle have. What the hell? Geometric. Here we see some weirdo inequalities. Reflections, rotations. Here we see Hopf vibration, the Lorentz group of special relativity. This book has it all. It's such a brilliant book to work through, but only for the exercises, because the theory is yeah. Then we come to Luscombe thermodynamics, which is a fairly rigorous thermodynamics book. It's all very done very right. And if something is done right, then it probably should not be your first book on the subject. So it has the first law, the second law, it has entropy, it has potential / radiation, so the blackbody radiation, it has chemical equilibrium, it has the third law, it has different formulations of thermodynamics, it has black hole thermodynamics, non-equilibrium thermodynamics. So this book really derives everything very carefully. but in a physical way, in a physics way, not in a math way. It doesn't bother with precise assumptions and precise statements. But it derives everything very precisely, and it does go into the meaning of what it all means quite a lot. This is really a book that I want to recommend to anybody who wants to get in deep territory of thermodynamics. It's very nice. Then by the same author, we have his special relativity book, which is a very in-depth book on special relativity, one of the most in-depth books on the special theory that I know of. So here we have, it starts with basic special relativity, the Lorentz transformations are derived. We start immediately with tensors, particle dynamics, so we have energy momentum, we have electrodynamics, hydrodynamics. It's towards the end, it goes towards general relativity on manifolds, differential geometry. We have Schwarzschild metric, the linearized gravity, relativistic cosmology. So it goes quite in depth in a nice, rigorous way in special relativity. This should not be your first encounter with special relativity ever, because it's going to be very confusing. But if you already know it and know a bit of the math behind it, I recommend it. I cannot recommend it too highly. Here we have Stephanie Singer, who is one of my favorite authors, and it's a very thin little book on symmetry and mechanics. So the book deals with the mathematics of classical mechanics. So there's a two-body problem, phase spaces. It starts with a bit of differential geometry, Hamiltonians, the Lie groups, Lie algebras, conserved quantities. So this book is a very short book on symmetry methods and how classical mechanics deals with them and the math behind them, so differential geometry behind them. Highly recommended, of course. Here is Kondepudi and Prigogine, a book on modern thermodynamics. What I like about this book is that it deals with both equilibrium and non-equilibrium thermodynamics, and it has a very nice historical point of view on things. So it starts with the first law, it goes towards the second law, entropy, extremum principles, gases, liquids. It has phase change, it has solutions. So it's very, you see, it's very chemistry focused too. So it definitely has a focus on chemistry, which doesn't need to be bad. Chemistry is a part of physics after all. Here we start with non-equilibrium thermodynamics. We get nonlinear thermodynamics. So the book goes really deep in a way that few other books really do. It derives everything nicely, and it's not that difficult of a book, to be honest. It also has a very neat vibe to it. I really love reading to this book. Then we come to another really good book. This is Imam, Covariant Physics, which is basically the math behind modern physical theories. So the paper is really nice. I love this kind of paper. Definitely buy this book because it's a very high quality book. So it has special covariance of special relativity, it has classical covariance, it has tensors, and goes all the way towards general covariance, physics in curved space-time, Riemann and Einstein, least action, differential forms, and generalizing general relativity. So this book is basically very geometrically focused and deals with the math behind everything. Highly recommended, of course. Very nicely written, very good exercises too. Then another book is Cox, Little O'Shea, the differential geometry book. Also a very high quality book. I love this book as well. The paper is really nice. It has a very computational view on algebraic geometry. Yeah, a view that few other books have. So it really shows how to compute things. So it's, you see here applications to robotics. You see here invariant theory of finite groups, projective, the dimension of varieties, and then all kinds of appendices. So this book is a lot of pictures, which should be the case for a geometry book, but modern geometry books don't have that too much. The book, yeah, is many algorithms which you can program. It's very cool to do so. Yeah, the book, I think it's the perfect introduction into algebraic geometry. I know there's Garrity too, but I think this book is slightly better. I like this book immensely. Then we have here a book which I've used so much that it's already a bit broken. So this is my Ohanian. Ohanian is the perfect book on electrodynamics. It does everything so right. It does everything starting with special relativity. So it starts fairly traditional. Electrostatics, boundary value problems. It goes towards dielectrics, electric energy, but then before they even do magnetism, they start with special relativity, space-time, relativistic electrodynamics, where they derive the Maxwell equations. And then we start with magnetism. They derive magnetism from special relativity and from the Coulomb force, induction. Then we come to light waves, and we come to radiation, resonant cavities, scattering and diffraction. So this book is, I think, the perfect book on electrodynamics, done in a very nice way, taking special relativity seriously, which is already kind of rare for books of this nature. Then another really nice book is More, the General Relativity Workbook. More is such a beautiful little book. It's not a little book, it's a very big book. It starts with special relativity, 4 vectors, index notations, and then it goes all the way to geodesics, and then it explores the Schwarzschild metric. There's photon orbits, deflection of light, event horizon. Before it starts with the general math, the Riemann tensors, for example, the Einstein's equation, and then it goes towards the cosmology of the universe, of the cosmos, cosmic implication, the early universe. Then it goes over things like gravitational waves, how we detect them, what they are, gravitomagnetism, the magnetic analog of gravity, and then we have rotating black holes, the Kerr metric, and everything. Highly recommended as your first general relativity book. Extremely nice book. Here we have Nahin, a logician and engineer, which is on George Boole and Claude Shannon. Boole, which of course invented Boolean algebra, and Shannon, which involved himself with information theory. It's basically a very readable pop sci book, but it's a very good pop sci book. It does do everything. Like you only need high school math for this, but it really does everything correctly with math in there. I really recommend this book to everybody. Nahin's books are all great, so I recommend them to everybody basically. Then here we have 2 books on music and mathematics, Musymatics, where it does everything to do with music and mathematics. So we have acoustics, we have basis of sounds, we have we have composition. Yeah, if you're interested in the link between math and music, this really is a book for you. Musical signals. It also goes into digital music, how to make convolution, filtering, spectral analysis. So there's quite a few Fourier stuff. If you want to know why Fourier stuff is useful, and if you're into music, this book might be something that you would like very much.